Hello students, today we are going to do Frenet formulae. So I will write the statement. Frenet F-R-E-N-E-T, Frenet formulae for a space curve. With non-zero curvature. So that torsion is defined. So let us derive first, then we will write the statement. So we know that n is equal to 1 upon kappa T dot so that T dot equal to kappa n. We have the orthonormal system T and B. This is an orthonormal basis and it's a positive system. So what is meant by positive system? T cross n is B, n cross B is T, and B cross T is n. T cross n equal to B, B cross T equal to n, and n cross B equal to T. So T dot is kappa n. Derivative of T we have found out, it is kappa n. Now we know B dot. We know B dot is minus tau vector n. This also we have learned. So this derivative also we know. Now, sorry, not this. This derivative B dot, that also we know, minus tau n, where tau is the torsion, and now we will compute what is n dot. So n dot, which is equal to, differentiate this expression. So what you will get? B dot cross T, B dot cross T plus B cross T dot, which is equal to, let us substitute for B dot. B dot is minus tau n cross T plus B cross, what is T dot? T dot is kappa n. So that is equal to, now what is n cross T? Look at n cross T. N cross T is minus B. From the first equation, n cross B is minus T. N cross T is minus B. So this becomes tau B Now what is B cross n? B cross n is minus T from the third equation. B cross n is minus T. So this is minus kappa T. So this is n dot. So Frenet's formula says that T dot equal to kappa n, T dot equal to kappa n, n dot equal to, what is n dot? Minus kappa T plus tau B. minus kappa t plus tau b, and what is b dot? B dot is, it is here, minus tau n, minus tau n. This is known as Frenet-Serret formula. As an example, okay, before that, let us observe one thing. T dot, N dot, B dot, this matrix equal to, I can write in this way, times T and B. So what is this matrix? So write this as 0T plus kappa n plus 0B. Similarly, write the second equation as minus kappa t plus 0n plus tau b, and write this as 0t minus tau vector n plus 0b. If you write this way, now you pick these coefficients, so you will get 0 kappa 0 and here minus kappa 0 tau, and here the last row becomes 0 minus tau 0. Now look at this matrix. This is Q-symmetric matrix. Means A transpose equal to minus A. This is Q-symmetric matrix. All the diagonal entries are equal to 0, and here kappa you have here minus kappa, here tau you have here minus tau. So Serret-Frenet formula can also be represented by means of this matrix. We shall do an example. Let gamma be a unit speed curve in R3. Let gamma be a unit speed curve in R3 comma with constant curvature kappa. Curvature is constant, and torsion tau equal to 0. Then gamma is parameterization of a circle. That's what we expect, because curvature is constant means it must be a sphere. A constant has a sphere has constant curvature, namely reciprocal of that radius of that sphere. Now torsion tau equal to 0 means the curve gamma is a plane curve. So gamma lies on a sphere and on a plane. That means gamma must be a circle. That's what we expect, and that is what we want to prove. Gamma is a parameterization of a circle, or at least part of circle. So how do we prove this? Curvature kappa is first we use torsion tau equal to 0. Tau equal to 0 means we have done this. Gamma is a plane curve. Gamma is a plane curve, lying in the plane perpendicular to, lying in the plane, in a plane perpendicular to the vector B. This we have seen. We have done this part in our previous class. Okay. Now we are going to explore the fact that kappa is constant. So look at gamma plus 1 by kappa n. You differentiate this. D by ds of S is the parameter of gamma. So this is d gamma by ds, namely gamma dot plus, you have to differentiate this term. So 1 upon kappa square in the denominator, kappa into n dot minus kappa dot into vector n. This is what we get. But kappa is constant curvature kappa. So kappa dot, this is equal to 0. Kappa dot becomes 0. So this becomes gamma dot plus 1 by kappa square into kappa n. So it is n dot divided by kappa. N dot divided by kappa. So now let us substitute for gamma dot and n dot. Gamma dot is precisely our vector t, tangent vector, plus 1 by kappa into what is n dot. From the Fresnel set, it is minus kappa t plus tau b. Minus kappa t plus tau b. Minus kappa t plus tau b. Right? But tau equal to 0 from here. So this is 0. So this becomes, and here you have kappa in the numerator and denominator. So they get cancelled. So t minus t equal to 0 vector. So derivative of this is the 0 vector. That means this quantity, that is going to be a constant vector. Let us say vector A. Therefore gamma plus 1 by kappa n, that is going to be a constant vector, vector A. Alright. Now look at gamma minus vector A. Take norm of this. What you will get? 1 upon kappa vector n, but norm of vector n is equal to 1, so it is 1 by kappa. That means gamma is a sphere. No, gamma lies on a sphere. This means that Gamma is a curve in R3 that we have already stated, and the norm of gamma minus A is constant. So this means that gamma lies on a sphere with center A and radius equal to 1 by kappa. But remember, already we have seen that gamma lies in a plane. Gamma lies in a plane. Now we have shown that gamma lies on a sphere. That means gamma lies on the intersection of a sphere and a plane. Thus, gamma lies on the intersection of a plane and a sphere. Therefore, gamma must be a circle. What is the intersection of a plane and a sphere? It's a circle. Therefore, gamma must be a circle or a part of a circle, at least. What is the radius of the circle? It is the same as radius of the sphere. Radius of the circle equal to radius of the sphere. What is the radius of the sphere? It is 1 by kappa, which is equal to 1 by kappa. And what is the center of this circle? Center of the circle is precisely A, the vector A. Center of the circle equal to vector A. And what is the equation of the plane in which the circle lies? In which the circle lies is, what is the equation of that plane? That plane, already we have observed that it is perpendicular to the vector B. So V dot B equal to a constant. Which constant? But can you suggest? So V represents an arbitrary point in that plane. Can you get a point in that plane? Of course, A, the center of the circle, lies in that plane. So A dot B, that is that constant. So in figures, you will get something like this. This is the, I will draw the sphere. Yes, this is the sphere. This is the center vector A. Gamma lies on a plane perpendicular to B. So if B is this vector, B lies at the origin. Remember. This is x-axis, this is y-axis, this is z-axis. If your B is like this, then translate it to the point A without changing its magnitude and direction. So you will get this as your new B. So you have a plane perpendicular to the vector B, on which gamma lies. So this is that plane. And gamma lies on this sphere also. So what I have drawn is a circle. So to convince that it's a sphere, just draw, what is that, the equator. and gamma lies on this plane. So this is a gamma. I will use a different color. This is your gamma. This is your gamma. An equation of this plane is V dot B equal to A dot B and equation of this sphere is norm of, it's not the parameterized equation I am looking for, it is norm of gamma minus vector A equal to 1 upon kappa. This is the equation of the sphere. This plane. Thank you.